ESR spectrum of ethyl radical. In ESR spectrum of ethyl radical, see, the odd electron is present in this carbon, which has 2 hydrogen, and the next carbon, which is covalently connected, which has 3 hydrogen. So these 2 protons, that is CH2 protons and the CH3 protons, they are not equivalent. Whenever we have non-equivalent protons, then the hyperfine interaction constant for CH2 proton and for CH3 protons are different. Okay, so now in this case what will happen? We have one odd electron, therefore we get one signal. Then that signal is split into many lines. How many lines we get? We have 2 different types of protons. So for CH2 protons, let me take the CH2 protons as A protons and CH3 protons as B protons. Therefore, we have the formula 2 into number of A proton into spin quantum number of A proton plus 1 times into number of 2 into number of B protons into spin quantum number of B protons plus 1. So we have 2 into A proton, we have 2, and the spin quantum number for proton, nuclear spin quantum is half plus 1 into 2 into number of B proton, we have 3 here, and I value is half for protons plus 1. So if we simplify this 2 to cancel here, 2 to cancel here, simplify, we get 2 plus 1 3 here and 3 plus 1 4. So we get 12 lines in the spectrum. Okay, we have one odd electron, so we should get one signal. That signal splits into 12 lines. Okay, and this is the intensity pattern. So the first line, this is due to the transition between electron spin state. That line is split into 4 by the methyl protons, and these 4 lines further split into, each line is split into 3 due to CH2 protons. So altogether we get 12 lines in the spectrum. Okay, take it. CH3X7 dot. So it is a radical species. The ESR spectrum of this radical shows 14 lines with the relative intensity 1:1, 6:6, 15:15, 20:20, 15:15, 6:6, 1:1. Okay, identify whether this radical is N-propyl radical, this is normal N, or isopropyl radical. Okay, is how to identify this. So what's the answer? The answer is very simple. Okay. Listen, for N-propyl radical, suppose if I calculate ESR lines for N-propyl radical, CH3, CH2 dot. See, we have 3 carbon and 7 hydrogen. Yes, you are right. Good. So we have one odd electron, so we get one signal, and that signal splits into many lines due to hyperfine interactions. Number of lines equal to, see, this CH2 and CH3, these are not equivalent. So if I take this as A proton, this as B, and this as C, they are all non-equivalent protons. Okay, then you can use N plus 1 rule here also. So for these 2 proton, N plus 1 rule if I apply, 2 plus 1 is 3. Then for the next proton, I will apply N plus 1 rule, 2 plus 1 is 3. Then the next one, 3 plus 1 is 4. So 3 into 3, 9. 9 into 4, 36 lines. Am I right? Am I right? Implies that the ESR spectrum is not due to N-propyl radical. Okay, so N-propyl radical, this is not the correct answer. Now let me take the next one, that is isopropyl radical. Isopropyl radical. So now we have a radical here. So it gives